Welcome everyone. We are discussing typical problems of second order derivative. These problems are most important for competitive exam. So look, first one. This is very simple problem, but you should know the technique. 2y equals to x into 1 plus dy dx. Prove that second order derivative is constant. So second order derivative is constant. So differentiating both sides, we differentiate it with respect to x. Since it is a relation of y and dy dx, no need of simplification. So 2 dy dx equals to x unchanged. So this is 1 plus d2y dx plus derivative of x is 1. X unchanged 1 0 plus d2y dx2 plus derivative of x is 1, so 1 into 1 plus dy by dx. So if we simplify, this is 2 dy dx, this is dy dx. So we are getting dy dx equals to x into d2y dx2 plus 1. So we are getting this relation. So differentiating again with respect to x. So this is d2y dx2 by product rule. This is d2y dx2 plus x into d3y by dx3. Derivative of 1 is 0. So d2y this one is cancelled. So x into d3y dx3 equals to 0. So since x not equals to 0, d3y dx3 equals to 0. Now we are getting third order derivative as 0. You know derivative of constant function is 0. So we can write d2y by dx2 equals to constant. So if second order derivative is constant, then third order derivative is 0. So this is simple problem. Now look it again. It is a relation between y, x and dy dx. So we differentiate it and we get a relation. Then differentiating again with respect to x, this one is cancelled, triple derivative is 0, therefore second derivative is constant. Someone will try to solve it by using concept of differential equation. So this is first order differential equation. Solving, you get a relation in x and y, then you can also solve. But this is the simplest way. Now we solve problem number 4. This is also very simple problem. Now look, y equals to tan inverse and this tan inverse. Prove that y2 equals to 0. I am repeatedly saying that to perform derivative of inverse circular function, you have to simplify it. So what is the simplification? So y equals to tan inverse. So tan inverse, this one unchanged. Derivative of, this argument is log x by x square. So you can write log x minus log e square and log e plus log ex square. Log e plus log x square. And this one is tan inverse 3 plus 2 log x by 1 minus 3 into 2 log x. So obviously base of log is e. If it is given or not in mathematics, if we write it in the form of log log, then also base is e. So this is log x minus 2 log e. Log x minus 2 log e. So 1 plus 2 log x. 2 log x. So this is tan inverse. So this is well known formula, tan inverse 3 plus tan inverse 2 log x. 2 log x. So it is tan inverse x plus y by 1 minus xy equals to tan inverse x. So this is compact formula. We can write it as a in terms of expanded formula. Now this one is log e. What is log e? Log e is 2. So tan inverse log x minus 2 by 1 plus 2 into log x. Tan inverse 3 plus tan inverse 2 log x. Now using same formula, tan inverse x minus y 1 plus xy. So this is tan inverse log x minus tan inverse 2. So look, so write it log e by x square. This one. So this is log e minus, correct it, log x square. Ratio of log. So this is difference of log. What is log e? Log e is 1 minus 2 log x. So x minus y 1 plus this. So this one is, you look, this is tan inverse x minus y 1 plus xy. So this is tan inverse 1 minus tan inverse 2 log x. So you can cancel tan inverse 2 log x. So finally you are getting tan inverse 3 plus tan inverse 1 minus plus tan inverse 3. So this is constant function. So y1 equals to 0. This implies y2 also 0. So this is very simple but most important problem. Now look, if it is given in terms of tan inverse or any inverse circular function, your main aim will be to simplify it. Next, Problem number 3. X square plus y square equals to t minus 1 by t. X4 plus y to the power 4 t square plus 1 by t square. Prove that y into y2 plus y1 square plus 3yx to the power 4 equals to 0. Now it is parametric function, this one. So final result does not involve t. So our main aim will be to eliminate t. Now x4 plus y4 is given, and this is t square plus 1 by t square. So you can write it t minus 1 by t whole square plus 2. Why we are writing t square plus 1 by t square in terms of t minus 1 by t? Because t minus 1 by t is given. So our main aim is to eliminate t. So x4 plus y4, x square plus y square whole square plus 2. Now this is x4 plus y to the power, this one equals to x4 plus y to the power 4, 2x square y square plus 2. So x4 is cancelled out. So finally what we are getting, x square y square, x square into y square plus 1 equals to 0. X square y square, x square y square plus 1 equals to 0. This is result not involving t. Now differentiating both sides. Differentiating both sides. So 2x into y square plus x square 2y dy dx equals to 0. So 2 cancel out. So y dy by dx so xy is cancelled, y plus x dy dx equals to 0. Y plus x into dy dx equals to 0. Now differentiate it again. So this is y plus x dy dx equals to 0. So x square plus y square plus 1 equals to 0. So y square equals to minus 1 by x square. So 2y dy dx equals to minus 2y x cube. So dy by dx equals to minus 1 by x cube. Now look at the final result. So differentiating again with respect to x, y into d2y dx2 plus dy dx whole square equals to minus 3 into x to the power minus 4. So 3y x to the power 4. So if you transfer this term to left hand side, you get a result. So if you eliminate t, you get relation in this form. So y square equals to this. Now look at the proof. So it is given in this form y dy dx. That is why we are writing y square here. Now we consider problem number 2. So this is also typical problem. A plus bx into the power y by x equals to x. Prove that x cube y2 xy1 minus y whole square. So given relation. So our main aim is to express y in terms of x. Therefore, e to the power y by x equals to x by a plus bx. So taking log on both sides. So y by x log e 1. So log x minus log a plus bx. So what is y? X log x minus log a plus bx. So this is our main aim, to express y in terms of x. Now dy by dx equals to log x minus log a plus bx. Log x minus this one unchanged. Derivative of x is 1 plus x into derivative of this 1 by a plus bx. So dy by dx equals to log x by a plus bx plus x into a plus bx so a plus bx minus a plus bx log x 1 by x 1 by a plus bx. So derivative of this is b also 1 by a plus bx into b. So a plus bx minus bx. So dx cancel. So dy by dx. What is log x by this? This is y by x. Y by x. And this is. So x cancel. A by a plus bx. So x cancel. Dx cancel. So dy by dx minus y by x equals to a by a plus bx. So this is our relation number 2. Now differentiating again. So d2y dx2 minus x square. So x into dy dx minus y into 1. So a by a plus bx whole square. A plus bx whole square. So a plus bx into 0 minus a into b. So finally what you are getting, you look, x squared d2y dx2 minus x dy dx minus y. So this is aby a plus bx whole square into x square. So you are getting this is x square. So dy by dx minus y by x equals to a by So look, we are getting dy by dx. So if you multiply x dy dx minus y equals to ax by a plus bx. So poly. So proof is given in this form. X y1 minus y. So that is why we are writing the problem in this form. Now differentiating again, x into d2y dx plus dy dx. So this is by product rule, minus dy by dx equals to a plus bx whole square cosine a plus bx into a minus ax unchanged into so ax we cancel, so a square by a plus bx whole square. Now this one is cancelled. So final result is x cube. So multiply by x square. So x cube into d2y dx. So ax by a plus bx whole square. So a square x square, that is ax whole square. Now this is x dy dx minus y whole square. So we are getting the final result. So look at dy by dx minus y by x. Final result is in terms of multiply it by x. So for it to then perform derivative. So you have to remember this step. So first you have to convert y in terms of x. So today through this video we have discussed some important problem of competitive exam. So if you want to get problems of competitive exam from limit, you may consult my videos of limit. There are 8 videos for competitive exam. Thank you.